Well, 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 space weather showed up a little bit early, and hence, so did we. And thanks for tuning into the Smash News Network, least busted name in news. Congratulations on realizing the channel exists. We're starting the video out today with some 24-hour videos of the closest star, that is the classic ionized helium wavelength, as major geomagnetic storm activity shows up, really strong magnetic fields, proton events, radio blackouts, and more to be covered. We're starting things out by looking at sunspot 3664, our T-mass, the most active sunspot. There's our 335 angstroms wavelength from SDO, just like the last video from Solar Dynamics Observatory. 335 is great at showing active regions. Here we've zoomed out a little bit and showed 131 angstroms. And yeah, that's one of the biggest solar flares of sunspot cycle 25, as we get the biggest geomagnetic storm in over 20 years. Here we've pulled in one step closer and shown 94 angstroms. Another of the many species of ionized iron covered by the Solar Dynamics Observatory. And guess what? There's yet another CME headed in Earth's direction. So as if that wasn't enough stuff, yeah, lots of stuff going on when it comes to space weather. There's the same zoom with 131 angstroms. We'll be talking about the power grid. We'll be talking about how to see the aurora. We'll be talking about where to find us on social media to share your auroral imageries and get them on the channel. And of course, we will cover all of the features that you may be used to here at the Smash News Network, least busted name in news. And if you're new to the channel, don't forget to press the like button and the subscribe button. Otherwise, how are you going to get the world's most comprehensive daily space weather content delivered directly to your YouTube subscription feed? How convenient is that? It's the Smash News Network, least busted name in news. We got you back when it comes to space weather. Now, one of the ways to figure out what's going on with space weather is to look at induction into the power grid. So that's our geoelectric field map that shows us actual induction in millivolts per kilometer in the actual power grid. So as you can see, it's already hitting a little bit early, as multiple CMEs likely to overtake each other as they've been traveling at all kinds of different speeds. This morning's was estimated to be over 1,000 kilometers per second. This one is showing up at like 700 kilometers per second. So varying speeds, and remember folks, you don't even need to see a solar flare to see a CME impact. Now that's the past 7 days. We've decided to put up a 1-week video once again, since there is so much flaring activity in the past 7 days. Might even be the most active 1-week period so far in solar cycle 25, and we're still like 5 months out from solar maximum. Anyway, let's take a brief step away from space weather and see what's going on planet Earth. And I mean very brief. There are volcanoes erupting. The Recanus Peninsula volcano has ceased erupting, while another one has started, Erta Ale, located in Ethiopia. There's a look at its basaltic lava flow. Mount Ibu's exploding, Luatobi, Luatolo, Semeru, producing a 15,000-foot plume of volcanic ash. Merapi, discrete volcanic ash there. Not sure if Popocatépetl is erupting, but Santiaguido is. Also Fuego, Nevado de Ruiz, Revenador, and Sabancaya. As far as earthquakes go, just moderate activity, no major quakes. Vanuatu had a 5.0. Taiwan had a 5.1. Taiwan had a 5.8. Was that last large quake in Taiwan actually a foreshock? Let's hope not. as that would have been a very large foreshock at magnitude 7.4. Indonesia also had a 5.1. Those are the 5 and greater magnitude quakes, and let's get back to space weather stuff. The 10.7 centimeter radio flux, which is a proportional data set to sunspot number, as you can see in this one-year graph, is now up to 233. 233 solar flux units is the current 10.7 centimeter radio flux. And yeah, it's a beautiful day in the space weather neighborhood. A beautiful day for a space weather nerd like you. Space weather nerd. Now, like we've been saying for days, multiple CME impacts coming, including one tonight, tomorrow morning, tomorrow night, and Sunday morning, well into Monday. Yeah, because another CME is headed this way. Now, keep in mind, this latest one is going to overtake possibly multiple previous CMEs. Again, because its estimated speed is over 1,000 kilometers per second. See our Twitter feed for more details on that. And there's the NOAA forecast. That's probably going to get updated. But you can see there multiple CMEs overtaking each other on their Enlil spiral, the graphical display over there on the left. As far as ESA, they've been pretty on the ball. Oh, also our magnetometers here at both Boulder and Corunna have been getting pretty jiggy. As you can see there, some major fluctuations in both the Corunna and Boulder ground-based magnetometers. Also, Tormestorp. Don't forget the Tormestorp magnetometer, consistently showing similar fluctuations. So here's ESA. And yeah, that's looking pretty consistent there. As you can see, coronal mass ejections overtaking each other due to large discrepancies in their speed. But the one from this morning is earthly directed. Again, make sure you follow us over on X, otherwise you'll miss a whole lot of things. And that's one of the places that you can share your auroral imagery. Also, you can always check out Instagram.com/Smashomash. So X.com/Smashomash, and also Instagram.com/Smashomash. If you've got auroral imageries you'd like to share, do it over there. Send a DM, or better yet, tag us in a post. That would be much more convenient. Tag at Smashomash in your post, and we may feature your imagery on the channel. So these are the past 4 hours of Earth's magnetic moment from space, and you can see very high magnetohydrodynamic pressure out there because major CME impacts with extremely strong magnetic fields, as we said in the previous day's videos. Of course, a CME impact is dependent on how strong the field is, and that's a really strong field. It's also a fast solar wind. The density is not all that high, but the strength of the magnetic field, the vertical component of the magnetic field being strongly southward, as well as the solar wind velocity. So that's the polar view of changes to Earth's B field, geospace delta B from ground level. We'll also show the full world view. There's the full world view. Yeah, major substorms will be kicking up. So people in Brazil, you may be able to see the aurora tonight. So yeah, I mean, that map is a pretty good map to show you where the aurora will be likely to be seen. As you can see there, we saw major magnetic perturbations making it all the way down to the center of the country there, most likely. That's our geospace ground magnetic perturbations map, and we'll also show just North America. So yeah, check it out. There's North America, and that's the strongest geomagnetic storm we've shown on the channel. So, and expect it to just simply continue here for a solid couple of days, folks. Now, keep in mind your power grid in first world nations is unlikely to get destroyed, as power grid operators shut down systems as well as employ electronics to shut down specific transformers before too much induced current occurs in the grid. Again, this is a good way to tell what's going on. That is empirical data, actual measurements of millivolts per kilometer in the US and Canadian power grids. So it's the geoelectric field map. You can find that and many other useful things at the Space Weather Prediction Center, part of NOAA's web ring. As you can see there, the KP index went all the way from 2.66 to 7.66 just within a 3-hour period. And you can expect it to possibly even go up higher here. So we've seen the strongest magnetic fields and the strongest southward component, the strongest negative BZ that we've seen as well since that last update. So the next update might be KP8. It all depends on a fluctuating solar wind, and it has been fluctuating. So as you can see here, the initial impact showed up right around 1630 Universal Time today on May 10th, another historic day for space weather. It's going to be a historic couple of weeks here, and perhaps even a historic solar maximum, as again, we're still 5 months away from solar maximum. So there you can see it showed up with some pretty fluctuating fields, but then we saw this very strong signal right in here. Again, that's since the last update. We saw the field there measured at ACE at 47 nanotesla with a BZ of negative 42. At Discover, even stronger, a BT of 52 nanotesla with a BZ of negative 47. That is some serious space weather. Also a higher density there being measured at Discover. Density is making it all the way as high as over nearly 70 protons per cubic centimeter there. So let's actually bring up the 6-hour here to get a little higher resolution of that. There's a 6-hour graph. It actually got above 70 protons per cubic centimeter there. So current conditions are still quite significant here. 58 protons per cubic centimeter at 701 kilometers per second with a BZ of negative 26 and a BT of 31 nanotesla. That's some serious space weather. Also, the GOES-16 had to undergo hours and hours of thruster use to maintain its geosynchronous near equatorial orbit, and hence may have tainted its own data there. So that arc-jet moment, that is to show you when its engines were creating plasma. And of course, plasma being charged particles can affect the magnetometer. So, but we do have nice readings there for the GOES-18 throughout the event so far. And fortunately now the GOES-16 has settled back into its non-thruster using Chilin orbit. So yeah, that's the 6-hour. Let's bring up we usually show the 3-day. There's the 3-day graph as a major geomagnetic storm strikes earlier than expected. Now, as far as heliospheric sectors go, Earth is still in a North Pole sector as we forecasted yesterday, but by tomorrow's daily space weather video, Earth is very likely to be in a South Pole heliospheric magnetic sector. That's going to really result in not a lot, but sector boundary crossings are associated with some aspects of space weather. So we show it just because we understand it. So this is our photosphere magnetism, the solar B field in blue, and the polar fields in red and green. Moving to coronal holes, we've got some South Pole oriented ones rotating in here as we have shown for days. And how about if we switch to our coronal hole wavelength? The preferred wavelength for coronal holes at the Smash News Network, least busted name in news, is 211 angstroms. So, and you can expect the uptick in coronal holes to do nothing but increase for the coming couple of years, because we've had a shortage of coronal holes to date for solar cycle 25. So you can expect a lot more, including trans-equatorial ones, which will do what? Anybody? They'll cause additional upticks in space weather. And for that, we thank you. Which brings us to sunspots. It's time to move to sunspots. They're kind of important, especially considering the performance of some of the sunspots recently, right? So sunspot number here is currently at about 165 sunspots. And let's look at the flare probability monitor and scoreboard here next. So, the likelihood of sunspot 3663, which has now set in the northwestern limb, producing a large X-class flare, is declining. However, the likelihood of sunspot 3664 is increasing. Why? Because it's getting closer and closer to that western limb, which pulls it up like by around 5%, which is quite a lot considering how active it's already been. So it hasn't degraded significantly in terms of its magnetic fields, and we'll show you some vast close-ups of those as well. Sunspot 3664, as forecasted, is now the T-mass, or the most active sunspot. There it is in your lower right, the southwestern quadrant. As it moves closer and closer to the limb, it may have actually grown a little bit here, but mostly stable for the past 24 hours. Now, a few minor groups have also risen in the east. We're not going to pay much attention to those because that thing is a serious solar flare baller. That sunspot is baller. There are a lot of deltas, and they are major deltas, which is when opposing magnetic fields are very close to each other. Sunspot 3664 has got deltas in spades, and again, has not degraded since yesterday. Look at all of those umbrae. That is a twisted up bundle of magnetic furious joy. And if you think that looks angry, I don't understand why. Not really that spooky. Here we've thrown in ionized carbon. Wouldn't it be nice to be able to grab a bunch of that ionized carbon and make a carbon bike out of it? You know, like a solar brand. Wait, I think there may be already... No, that's solar. I don't know. There's some brand called something like that. Is it Dolan? I don't know what it is. But yeah, imagine a carbon bike with pure solar carbon. Of course, that carbon there is highly ionized, where you see that flare happening and all that white occurring right in there. That is a lot of carbon. Just kind of showing up. Yeah, it's just kind of showing up. Is it showing up because of fission and fusion? Let us know what you think in the comments. Perhaps that's too controversial for you. There is the continuum view, 24 hours at FPS 30. The Solar Dynamics HMI instrument, continuum. And here at the Smash News Network, Least Busted Name in News, we thank Gond for the SDO, or whoever built it. Does anybody know if the SDO was built by Gond? Like I said earlier, we have a proton event, and it's now a major proton event because it's, well, I mean, we don't have the higher energy levels really getting too crazy there, but the lowest energy level there is quite significant, and it's causing significant polar radio blackouts. As you'll see here, starting with the North Pole, as we forecasted yesterday, and then including also the South Pole. So major radio blackouts, both around the equator at noontime, as well as at the poles. Yeah, polar communications are not going to be faring so well. As far as the X-ray flux goes, it's, again, like I said, been interesting. And the latest large flare was about an X4. Very close to an X4, about an X3.98, I think I saw there, something like that. We'll just call it an X4. And that brings us to our solar system forecast. So we'd like to show where things are. And we hope you enjoyed New Moon. We've got a crescent waxing now. That's where things will be in 1 week. And that is our solar system forecast, brought to you by theplanetstoday.com. As far as what's going on overhead, I like to use skyandtelescope.org. They've got a lovely star chart. As Mercury sets over Lehigh Valley, Pennsylvania, just put in your location, and you can have your own star chart. Today's astronomy picture of the day is really a video, not so much a picture. And it's an artist's rendition of gravitational lensing, which was discovered in 2015. So it's believed to be two merging black holes at a distance of like 1 billion light years. And this entire event here is believed to have taken like a millisecond, but it's slowed down to show what may have been seen there as, background stars are shining through there. And of course, it's believed to have ended up with about 36 solar masses, losing about 3 solar masses to energy, which it put out as, quote, gravitational waves, and, quote, if you want to read more about that, check it out at apod.nasa.gov. apod.nasa.gov. Light, it gets distorted when going past things in space, especially massive things like massive radio sources. Now again, this morning there was yet another Earth-directed CME. Its estimated velocity is over 1,000 kilometers per second. So if you see a halo early this morning, right in there, that would be yet another earthly directed CME. So here we've paused this. 224 for the C2. We've got it at 354 for the C3. We're going to let that get a little bit ahead. And there you'll see yet another partial halo coronal mass ejection. So yeah, space weather. Good times for it. We'll also show stereo A, and we'd like to show this imagery to show you where stereo A is located. It's actually speeding west away from the Earth in that direction. And, we prefer to see CMEs when you have like the Parker Solar Probe or the Solar Orbiter in between the Earth and Sun, because we can get an estimation of how hard of an impact it's going to be. This time, we didn't have any such thing, as you can see. Bepi, the Parker Solar Probe, and Solar Orbiter are all on the far side. Anyway, we've paused stereo A here at 909 for the difference imagery and 809 for the raw imagery. It's a pretty boxy looking CME. Let's bring those back. And there goes that halo from this morning. Now, that will largely miss Earth to the west, but there still will be another earthly component. So that won't be a direct hit like the one we're seeing now. That will be more of a glancing blow. But again, it depends on the magnetic fields. Remember, folks, magnetic fields do propagate through, quote, empty and, quote, space. Anyway, here come our custom coronagraphs, and my. Not too bad. That's another 24-hour video at 30 frames per second. And those lines you see on the right and left, those are on the left Jupiter, and on the right, that is Venus. We aren't zoomed out far enough to actually show those, but that's what they are. Here's a little closer look, and that CME from this morning originated from right down here. And you can see from where the Hyder flare happens, the Hyder flare, which is plasma splashing back down toward the chromosphere, occurred right in this area right here. Right there, you can see that Hyder flare happening at the same time as that plasma splashed back down. Plasma was exiting the corona. So some of it is coming this way, and some of it was headed back toward the photosphere. That's the surface of the sun where sunspots occur. And last but not least, we'll zoom way in to show all the gory details of those plasma eruptions. And it's a fitting time to move on to filaments. And we have major ones continuing to populate the Earth side of the solar disk. So let's check those out. Starting out with Cerro Tololo, Chile. So there you go. You can see filaments. There is a major one in the southern hemisphere, which was part of the eruption from this morning. And then in the northeast, there's a really massive one. So anyway, that's filaments. You can see them. I don't need to explain it. And We also show the grayscale imagery from Cerro Tololo's ground-based hydrogen alpha telescope there to show prominences. The Charles Barkley prominence down there in the southwest is still quite prominent, just like Charles Barkley's opinions on things. Again, make sure you follow us over on Twitter. Otherwise, how would you name filaments after your friends, your foes, or even yourself? So, for example, if you want to name this filament right here after, I don't know, Bill Nye the Science Guy, just go over on Twitter, put in a post and put hashtag name that filament, and then tag at SmashoMash. Put an arrow to the filament you want named, and you can name a filament after your friends, your foes, or even yourself. Hashtag name that filament. And this is correct. I don't follow Dutch synths, nor would I follow Dutch synths, since I understand enough about science to not partake in utter nonsense and crap content on YouTube. All right, so here are the past couple of hours. Keep your eye on that sunspot 3664. Its likelihood of producing X-class flares, as I said earlier, is only rising in the coming days. Although its likelihood of producing more Earth-directed CMEs or being associated with more Earth-directed CMEs is low, filaments can happen with no warning and with no solar flare associated with it. Again, the likelihood of major proton events is going up, and you can expect this current radio blackout to last for a few days, possibly even as much as a week, because we may get additional infusions of relativistic protons, which are now orbiting Earth's magnetic field force lines with such furious speeds that they're emitting radiation. That is what is causing those polar radio blackouts. Solar protons. Anyway, here come bonus features, and as far as charging hazards go, we've got some charging hazards of the surface charging variety when low-energy electrons build up on the outside of spacecraft. Surface charging is what we're talking about, but it is minor. Electron flux here is dipping down, as you could expect. It's becoming an erroneous reading as we speak because of a major coronal mass ejection impact. It will stay really low probably for days, at least like about 48 hours, probably more like 3 or 4 days, and then it'll finally come back up, and we'll get a major increase in the electron flux. That's the 1-year graph of the relativistic electrons. So there's the forecast model, and NOAA's either going to change its forecast or be way off with its next update. In fact, its next 3 updates there, those will all be off by a lot. Next is our ionosphere section. We'll show the ionosonde, the anomalygram, the total electron content, and the maximum usable radio frequency. The F layer is at about 300 kilometers of altitude, and here is the ionosonde. So that's what's going on overhead. And you can expect to see a lot of low-frequency anomalies for the coming 3 days. Here is the anomalygram. It depicts anomaly in megahertz from a 30-day median. This data courtesy of Australian Government Bureau of Meteorology. There'll be a lot of red on tomorrow's Daily Space Weather video. So here's our global ionosphere nowcast depicting total electron content as well as anomaly and maximum usable frequency, maximum usable radio frequency and anomaly. And yeah, some big time anomalies showing up. There are going to be a lot of ions in between your GPS satellite and your handset. So there it is, the global ionosphere nowcast. We'll close out the space weather section with some up-to-date you better be up-to-date. I've pressed refresh. There we go. That one refreshed. There we are. Anyway, here's a close-up look one more time at sunspot 3664. It still has lots of deltas. It is still very likely to produce an X-class solar flare. somewhere just this side of 100% likely. And let's move on to viewing the aurora. Yeah, so the first thing we're looking at here is nullschool.net's total cloud water, and that's bad news, folks, because a lot of the country has cloud cover. So that is suboptimal for viewing the aurora. We'll show you other methods by which to check it out, but total cloud water is one of the ways. We'll get back to that in a minute. First, the surface winds and jet streams of the entire planet. Surface winds shown there, jet streams. Jet streams. Surface winds. Shout out to our viewers from all around the planet. Surface winds of the west and the jet streams. Satellite imagery, and check it out. This is another way to see how cloudy it's going to be, obviously, using the visible satellite. And yeah, lots of clouds over the western world. Suboptimal. So we're hoping things clear out by tomorrow night, but tonight is looking like a complete washout for Pennsylvania. Although the western part of the state seeing some breaks already forming here. So fingers crossed for that. Another way to check the clouds would be look at the visibility map on windy.com. Windy.com, all kinds of different layers you can check out there. And of course you can use the shortwave radiation map to show clouds and fog even at nighttime. So if you want to see what the trends are like or see what your window's going to be like to be able to see the aurora, the shortwave radiation map works great. It's part of the NASA Interactive Weather Satellite Suite. Right there, that's what it looks like, the George C. Marshall Flight Center. And it is not bad. Not bad. Clouds, they emit radiation. Use that to your advantage using these interactive weather satellites and win at life. Here's weather.gov where you can get forecasts. And we do have some severe weather forecasts in the Carolinas. Also some winter weather warnings on Mauna Loa and Mauna Kea. Yeah, some snow. Some major snow coming to Hawaii. Anyway, we scrolled down to show you the key. We showed you the map. And here comes some forecasts from tropicaltidbits.com. Tropicaltidbits.com. You can follow Dr. Levi Cohen on YouTube, on Twitter, on Facebook, on Instagram, whatever you like. Tropicaltidbits.com. Here's a 72-hour GFS temperature anomaly. Not temperature anomaly. That's a pressure and precipitation forecast. Yeah, pressure and precipitation. It looks like some of the snow for places like Montana have been downgraded to rain. Somebody will get mad about it, I'm sure. Make sure you leave a rage comment to tell us that you're mad that it rained instead of snowed in Montana. We're very interested. Snow still falling, mostly in the hot air capital of the U.S., though. So interesting. I guess maybe the hot air in Colorado's weakening. I don't know what's going on there. Geez, it's looking a little bit on the cool side. And I have nothing against the geography of Colorado or the average citizen of Colorado. I just have beef with some unaverage citizens of Colorado. Some subpar Coloradans. Oh, yeah. However, don't forget Dr. Scott McIntosh is the exception that proves the rule. Also, Jamie Carney. Shout out to Jamie Carney and Scott McIntosh. We hope you get a load of the aurora tonight. Anyway, here's our total accumulated precip forecast for the next 72 hours in inches. Here is our temperature anomaly forecast in degrees Celsius for the next 72 hours. They're all the GFS model. We could show different models. I just choose not to. We also had some major lightning make its way across the Gulf states, as you can see there, especially Florida. Florida and southern Georgia. And here's a real-time lightning map. Things have degraded to scattered thunder showers. So things are pretty chill now across the U.S. I mean, there you go. There's your real-time lightning map courtesy of lightningmaps.org. It's fantastic. Next time you hear thunder, it's highly recommended. And speaking of which, There's some rolling in there at Clinton. There's the full globe map. And it's pretty average right now at about 150 to 250 lightning strikes per minute. We'll close out this video by showing the drearily, drearily putrid skies of Pennsylvania. Yeah, plenty of rain. Plenty of rain, which is a pain when it falls on the plain. When you're not in Spain. By the way, I'm an actual published poet, so I try to stay away from the shtick on the channel. I try not to do shtick. However, we do like to keep an eye on it. And when I say eye on, I mean the closest star, you know. Smash News Network, least busted name in news. We'll close out the video with U.S. Doppler radar. Visible satellite. As a low loiters, a weak low loiters over places like Indiana and Ohio. It's cold air from Canada, though. It's going to push some dry air through, and things will warm up a little bit. It is quite chilly in Pennsylvania. Here's your recap U.S. Doppler radar. Visible satellite. And the water vapor map. And don't get me wrong, folks, of course, prepping is brilliant. We do encourage people to prep, have battery backups, have a generator, have a bug-out bag, and so on. However, we prefer to not create false alarmism over things that aren't alarming. Anyway, we'll see you next time. And in the meantime, don't forget to share your auroral imageries. If you catch the aurora, if you think you see the aurora, make sure you try to take picture or video of it, because it's mostly ultraviolet light, which means the naked eye can't even detect most of the aurora, so just keep that in mind. Anyway, we hope to see you soon on the interwebs. In the meantime, may that solar wind be at your back, and that nonsense be absent from your YouTube subscription feed. What?